Data analysis expression, popularly known as DAX, is a formula language used in Power BI to create calculated columns, measures, and custom tables. So once you master DAX, it gives you total control over your visuals and reports, allowing for better performance and flexibility within the Power BI interface. So welcome back to Excel Island, where we are trying to learn and master the Microsoft Power BI tool over the next 100 days. Today is day 40, and we are starting a new course in the series, which is DAX function in Power BI. We'll be learning all about the DAX language, which is one of those languages you need to learn as a Microsoft Power BI or data analyst or expert if you want to become quite good in data analysis in general, because you're actually going to learn DAX within Power BI, also in Power Pivot in Excel, and sometimes in SQL, DAX also work in some ways because there are some functions that are quite similar to the DAX language in other BI tools also. So in the first chapter of this course, you'll be learning how to create custom functions to create new measures and new table or new calculated tables in general. So welcome back to Excel Island. Also, all data files, exercise files, Power BI files that we're using to learn so far for the last 100 days, for the next 100 days rather, is already linked under the YouTube description. So do make sure to download those files and practice along with me. So without further ado, let's jump back to learning, and welcome to day 40, and welcome to this DAX function in Power BI learning journey with me. So basically, we'll be using the DataCamp platform so far. If I go to the career track section under the DataCamp platform, we actually enrolled in the data analyst in Power BI career track. So when I started this little fun way of learning and upskilling myself as a data analyst, I started with the data analyst in SQL career track. So we finished that data analyst in SQL career tracks for a 100-day journey also. Then we started the data analyst in Power BI career track, and we're actually 53% throughout the whole journey. So definitely after finishing this data analyst in Power BI career track, the next learning goal for the year 2024 is the data analyst with Python, which is also a career track on the DataCamp platform. So you definitely want to subscribe right now, put on the notification bell so you'll be the first to know whether I go live or drop a new content on the channel. So if I jump back to data analyst in Power BI career track real quick, you can see that we've covered quite a lot of learning so far. From this introduction to Power BI, we actually covered to the last case study here that we did. That was the last lesson. We did a case study in HR analytics in Power BI. It was quite interesting. So far, so good. We've done 2 case study from the beginning of the journey, which is this customer churn in Power BI also. Another case study. So you can catch these case studies and other lessons in the previous live stream on the channel to go on. So let's continue from where we stopped here. We'll just continue course. So I'll just start afresh from the beginning because I was trying to actually learn it yesterday, but that network just start from the beginning here today.
Hello, I'm Carl, and I'll be one of your instructors in this course about DAX. DAX stands for Data Analysis Expressions and is a formula expression language used in multiple Microsoft tools such as Power BI and Power Pivot. DAX formulas include functions, operators, and values to perform advanced calculations and queries. It's used in measures, calculated columns, calculated tables, and even for row-level security. Let's focus on the first 3 in this chapter. What makes DAX so powerful? First, it opens up many new functionalities. You can use joins, filters, measures, and calculated fields to perform complex calculations and create visualizations not possible before. Combining DAX and Power Query together provides a powerful data analysis tool. You can dive deeper into the data to extract key insights and use DAX for rapid prototyping. In DAX, it's important to understand the difference between measures and calculated columns. In calculated columns, DAX computes a value for each row when importing data. In this example, we calculate the cost for each row by subtracting the profit value from the sales value. Measures are useful to aggregate values and when you don't need a column added to your data model. In this example, this measure calculates the sum of all sales. Depending on how we segment the data or use filters, we can see the sales per region. DAX calculations change depending on how the context is set. There are three types of context: row, query, and filter context. Because of that, it's crucial to understand how different contexts work. Context enables dynamic analysis, where the results of a formula change to reflect the cell selection. For instance, if you exclude a sales region from a dashboard, the total sales will change. The results of calculations will change depending on how you use the row, query, and/or filter context. Row context is the simplest and evaluates at the row level. It includes all values in the current row. Therefore, DAX formulas for calculated columns evaluate at the row level. The calculated column from before is an example of row context. Query context refers to the subset of data returned by a formula, which can be changed by slicers, page filters, table columns, row headers, and interactions with visualizations. It applies on top of row context. Query context is what we mainly used in the introductory Power BI course. Our visualizations changed by adjusting a filter on the report pane or selecting elements of a viz. Here, we can change the query context to be at the region or state level to see two different results. Filter context is the set of values allowed in each column or when the value is retrieved from a related table. It can be applied to arguments in a formula or by using report filters on row and column headings. This context applies on top of query and row context, meaning its effects are lost. Here, there's a DAX formula using calculate that filters on the East region. We'll go deeper into context filters during the exercises. It's crucial to understand how different contexts will impact your visualizations. Calculated columns evaluate data at the row level, while you can use different filters and slicer to change visualizations in your report pane. This is the query context. Finally, you have the filter context as seen in the previous slide with the calculate function, which can use arguments in a DAX function to filter for fields like region. We'll be using the worldwide importers data warehouse in the exercises. This is a fictitious dataset about the imports and distribution of novelty goods of a wholesaler. It mimics a typical database you'd find in the real world. There's one fact table containing sales transactions and multiple dimensional tables detailing dates, customers, cities, employees, and items. It's time to start your journey on becoming a DAX master. Enjoy!
Okay, off to plans. So good news. That's quite interesting. So I'm quite familiar with row context and filter context. I never knew there was something called query context. That's quite interesting to see. Okay. So it says row versus query versus filter context. So context is an important concept to understand when building and creating DAX formulas. Understanding how DAX evaluates functions will help with building more complicated analysis. So categorize these statements into the corresponding context box. So this context includes values from all columns in a current row. Include value from all columns in a current row. That should be row context. Applies to visualizations via explicit formulas in the filter expression of DAX. We say filter context. Evaluates at the row level. I'll go for row context. Control by slicers, report filters. Let's see. Okay, so control by slicers. By slicer, that will be query. Control by slicers, report filters, and columns. That should be query context. Applies on top of row context. And that should be query context. Because query context is more powerful than row context. Apply on top of other context. That should be filter context. Because it's quite more powerful than the other two. Oh, we nailed it. So amazing context knowledge. Now you understand the difference between row, query, and filter context. It is time to start applying it in exercises. Okay, that's quite interesting.
Let's get started with making calculated columns and tables with DAX. I'll be working with the Contoso dataset, which is different from the worldwide importers data you'll be using in the exercises. The structure of both tables is similar though. They both contain fictitious data of a retail company. There is one main fact table with transactions and different dimensional tables. In this demo, we'll be going through 3 different functions. First, we'll create a calculated table, after which we'll investigate 2 different DAX expressions to create calculated columns. When looking through the different dimension tables, we notice there is no dimensional date table. Let's use DAX to create it. We navigate to Table Tools in the Data pane and select New Table. First, let's name the table dim calendar. We need to use the calendar function for this exercise. This function creates a range of dates between the 2 arguments used. Notice Power BI always explains the function you will be using as you are typing. Let's create a set of dates between the min and max date of the fact table. Notice I press Tab here for the full date name to appear automatically. It's that simple. We already have our date table ready. There is a hierarchy in our new table, so let's move back to the model view and connect it with the fact table by dragging date to date key. By doing so, we establish the relationship between both tables. Secondly, let's create a calculated column. All fields in the entity description column in dim entity table start with Contoso. Let's create a shorter version of this column with Contoso removed by using the substitute function. Let's click on New Column. We name the column Entity Short. Once we type the function, the explanation pops up again. We enter the column where you want to replace value, entity description, enter the alt text Contoso, and a text we want to replace by, a blank in this case. We press enter and see Contoso is now removed in all rows. Thirdly, we'll bring in a column from another table. In the fact table, we can only see the key, but sometimes it's useful to see the actual value it represents as well. The amounts in our fact table are related to a scenario. When investigating the scenario table, we see it as an actual, budget, or forecast. Let's bring that in. We can do that using the related function. This function returns a corresponding value from another table. Power BI knows what to do because the relationship between the 2 tables is already defined. Finally, let's visualize the amount by scenario name over time. We navigate to the report pane and create an area chart. We add the date from the table we created to the axis, the scenario name to legend, and the amount to values. That way, we can compare the amount per scenario over time. Using the drill down button, we can now see how the forecasted, budgeted, and actual amount compares quarterly or even monthly. That's it for the demo. Over to you so you can start using these new functions in the exercises.
Okay, so let's use the new functions to solve the exercises. So after the lessons, we actually have the exercises to solve. You can see the first exercise is creating a date table, then calculated column for cost, dates cleaning with DAX, connecting data from different tables. Okay, so the first instruction is dimensional table are necessary to ensure that calculations such as DAX time intelligence functions have all available dates. So this ensures there are no gaps between dates, so you don't receive any error while performing this calculation. So in this exercise, you will create a delivery dates table because we already have a dates table for invoices. More specifically, you will create a dates table that ranges from the main delivery dates to the max delivery dates. Okay, just like the way you did it there. Okay, we have the DAX functions cheat sheet, but let's follow the instruction. So everything is prepared within DataCamp. So I just open the file within my Power BI desktop here. So open Power BI calculated table. So let's open the file calculated table. So you actually have access to all the files using the link under the description to make sure to download those files from there. So, and navigate to the table tools in the data view. But before that, we actually need to connect back to this data. You can see all this dim city, customer, employee, invoice dates, stock item, fact table, worldwide importers, So if I go to the table view, we'll see a view of the whole data set here. But mind you, because we are downloading this data from DataCamp platform, we will need to connect back to the actual data sets from the data source here. So I'll just go back a little bit to the data sets. Ooh, worldwide importers. I can't find that here. So I'm looking at, I have access to the dim city here. What is this called? This is called data sets. This is quite interesting. It's pointing to data sets. But let me just close this real quick. If I go back to the table view, okay, this is just pointing to the oh, this is actually pointing to the file or the data sets. I can see the folder paths here. I can actually use that to navigate to the folder paths on my own local machine here. Interesting. But you have to be careful which data set is this city. Okay, valid to interesting. So I'm going to figure it out. That's quite easy to do. I think I'll figure out this first one. The first one is just pointing to the old data set folder. So this the old data set folder was actually loaded. Okay, so if I go back to transform here, if I go to this file path data sets, I can actually point to the data sets. Let me just delete all of this and just point to the folder paths on my, just to make it easier, I can just copy the folder paths here, copy as paths and paste it. But I also removing the file paths here. You see, so everything should work fine back. But I'm curious to understand how this dim city, you can see folder paths. It will be pointing to the folder paths. You see, folder paths, data sets, chapter 1, 3, and 4. Okay, let me look at it. Oh, it is 1, 3, and 4. But I'm seeing 1, 2 here. It's quite funny which folder path it was connected to. Dim city, because the data set was, it's quite not that straightforward. It is quite scattered. So the folder path is 1, 3, and 4. Let me look at this folder path also. It is picking it from my folder path here, which is kind of hard. If I try to move to this, there's going to be, the key didn't match any rows in the table. So there's going to be a breakage. It's picking it from my folder path. So the data sets were connected quite differently. That's what's causing the challenge here. They're connected to the folder paths quite differently. But I could just ignore it and make use of the DataCamp interface. But I'll try to figure it out first before actually giving up or trying it later. I've actually pointed to the folder paths for my own local machine here. The next thing is try to figure out, let me just close and apply first. Try to figure out, let me wait for it. If I go to the table view, Let's see if it's going to apply. Okay, they're going to be blocked. So interesting. If I go to the table view, if I look at the dim city table, I could actually guess city key. How many rows do we have here? Over 16,000 rows. 116,000 rows. Okay. Let me see if I can open the dim city from this chapter 1 here. Okay. I'm trying to open the actual folder file. It's up to 116,000 rows. Oh, it's exactly 116,000. So I think I found the folder that was actually used. But if I look at the other one, let's see. Probably they are the same thing. Oh, okay. Oh, okay. I think I figured it out. I think so. So let's give it a shot one more time. If I go to the transform tab, let's pick on dim city to the source file, navigation file, equals to World Wide Web imported. Okay. Which is this one here, because that's the source file there. Hmm. This is quite interesting. Hmm. Hmm. The source is this folder part here. So I can't actually change. Let me see if I can change it from here. Interesting though. Hmm. Okay. How about if I click on this? No, I don't want to insert it. Okay. Right, I can specify the source to navigate to. Okay. Oh. I think I've destroyed the navigation part there. Interesting. Oh, okay. Let me give it one more try. If I actually make use of the DataCamp platform, if I look at the team stack, my navigation is back. Okay, if I decide not to point to the source, which is this navigation, okay, let me give it one more shot. Let me go one more shot. If I can't troubleshoot it, I'm going to go back to the DataCamp platform. Click on OK. So you can see this is my source for the data sets. So it's quite interesting to figure out how they were able to connect to this source to this source here. Hmm. What do I do? Importers, then the dim city here. Hmm. We look at the navigation. Yes, the key didn't match any rows in the table. Details, key, folder paths. Okay. When I click on edit settings, hmm. Contents. Oh, I think I figured it out. Whew, I can't figure this out yet. So I'll probably just copy this error and troubleshoot it later. So, but not to waste any more time, I could just close and apply. I definitely want to practice this DAX function within my own Power BI interface. But as it is currently, I won't be able to do that. Hmm. Okay, the source. Okay, let me go to the advanced editor and see. Source is this user. Oh, okay. I think if I can change the folder path here to my own folder path, I shouldn't have any issue. Hmm. Let's see. Let's give it one more shot. I'll just go back to my folder paths. Let me look at that advanced editor again. User data sets. Hmm. Okay. Okay, I think I know what to do. I'll just click on copy as paths. Okay. So this part here, let me give it a space first. So this part here, if I delete this part here and paste my own parts, user, okay, okay, Control C, I'm having two space here. Oh, I'm supposed to be having one there. Trying to see if I can edit this. Okay, I'm giving it a shot. If I decide to go and use the DataCamp platform to solve this, so C sharp equals to source. So I'm not pointing back to the source folder here. Okay, I think I've seen my mistake here. So I shouldn't delete everything right from here. Let's see. Ctrl V. Hmm. So the folder path is not correct. My folder path has changed from DAX. Okay, let me change this folder path here. Okay, so I can't edit this for now. So what to do? The only solution now is to make use of the DataCamp interface for this challenge. So I'll just stick to this interface to solve this. Except I want to point to the data sets from scratch myself. If I go to new data source, for the data set, there are two different data sets here in the same folder. Well, this is chapter 1 and 2. So if I point to the data set again, we should have it here. Okay. So I could just delete this. But all this, let me go back a little bit. All this step, you can see, I think the first step was remove top rows, change data type, remove top rows, promoted headers, and what row did they filter? I wanted to figure out what row they filter. The first important task they did there was to remove top rows. Remove top rows. Okay. With top row and then promoted header. If I look at the step, remove top rows, promoted headers, then these headers were promoted. Use first row as headers. So we've done that. But the next task is to figure out which rows were filtered. What was actually filtered there? I could steal it, but I couldn't see that. But if I go to the advanced editor, I could see filter rows city key. So the rows were filtered to what? So you may not be able to figure out which rows were actually filtered. I could recreate the steps that was done. So filtered rows, table dot selected rows, its city key is not equal to 0. If I look at my own advanced editor here, you can see all same step, but the only part was the source was different. You see that? So if I want to make use of this step that was done here in this advanced editor, I could just copy it, filter those. I could copy this part, copy, come to my own advanced editor here, and just paste it as part of the step here. We have to make sure I'm referring back. So after each step here, there's a comma. So I bring in a comma, hit enter, paste my selected step. The filter goes equals to show error. I need to make sure I delete this last step here. Okay, filtered rows, table dot selected rows. So it's going to go back to this table and effect that changes. Let's give it a shot. Aha. So I was able to probably I'll just do that for the remaining of the data sets here. So since I've done this for the dim city, I could actually get rid of it. So that's one way to also actually solve this challenge of connecting the data. Because I actually have the data file, the CSV file. So I could just figure, but let me confirm this 15 columns, 999 plus rows. What about this? How many columns? Ooh, I may not be able to know how many columns were actually filtered here. So it's not going to show me. That's another challenge also. It's only showing you 8 columns 12 goes based on what is showing here. But if I'm not mistaken, so everything should be fine. But if I can go back to this dim city, let me give this dim city 2, just for differentiation's sake. So that's that sometimes. My dim city 2 is not coming out here. But I want to make sure I look at this dim city. We have 116,294 rows. 294. Okay, I'll just go with that. I think I'm on the right track. I could actually just get rid of this dim city, delete it from the query. So if I do the same thing for the customer, so filtered rows. So if I look at the advanced editor, they're actually performing filtering rows for each, but it's almost the same thing can be done. So if I bring in this customer table, let me just change this dim city back to dim city. If I look at the customer, I'm going to bring in data source, then the customer, dim customer table, and apply the same transformation to it. That's it. I think almost the same thing. So I'm going to remove one first row, remove top rows, which is one row. Then promote, use first rows as headers. Then the final step, if I look at this actual customer table that was gotten from remove top rows, promoted first rows, change data type, we are performing the same thing. But the challenge I'm having is trying to figure out this last filter step. So I could just copy this last filter step from here and make use of it in my own query here. So I'll give this a comma, then paste that step. So I could get rid of this step because this is the last step here we want to have here. Done. So we don't have any issue again. I can get rid of this one here. So I just hope I'm correct. So I'll bring in invoice date, new source, which is the invoice date. Okay, this is for chapter 1 and chapter 2, so I'm correct. Where's the invoice data? Ooh, there's no invoice, dim invoice date here. Oh. That's another challenge. Wow. Wow, wow, wow. There is fat sales. Let's bring in the fat sales data. This is the fat sales here. We have the fat sales here. Just bring that in. It's kind of challenging, but we're going to solve it out. Let's look at what was done here. Just promoted headers and change data type. So same thing. Promoted headers, change data type. There's no much transformation that was done here. I could get rid of this. What about the employee? Dim employee sheets, promoted headers, change data type. Let's bring in that employee. Of the employee data here. Ooh, where's the employee data sets? Okay, let's bring all file. Okay, we have it here. Oh, the dim dates, invoice date should be here then. Employee is not a CSV, it's a worksheet. So I chose the wrong data type there. Workbook. Okay, dim employee is here. Interesting. Ooh, imagine. Okay, employee key. Okay, if I look at this dim employee, the only promoted headers, then change data type. Okay, so we are on track. I will get rid of this employee from here. So we have this set here. What about the stock item? Okay, we don't have the stock item. That means it's a CSV file. Stock item here. It is actually named dim stock item. So if I bring that in, we'll look at the transformation that was done to the stock item. You can see, let's look at what was done here. Remove top rows, promoted headers. We're going to remove this first row here. Remove top rows. There is just one row. Then we're going to promote this first row one as headers. This first rows as headers. So let's look at the stock item. That was all that was done. Then the data type is going to change automatically. So I could get rid of this stock item here. But this invoice dates, that's the challenge. Come on. I don't have any file here called invoice dates. Dim city customer, dim date. I think that should be dim dates. Yes, that should be dim dates. Dim city. Let me just close it first. I'll just compare the content that was in those file. Okay. If I go to data view, I want to go to the invoice dates. The dates, I think the date is unique for each row. First, second, third, fourth, fifth, sixth. Let's look at the invoice dates here. The dim dates. First, second, third, fourth, fifth, sixth. I think this is the actual date. We have the day number, day. How many rows do we have here? Day number, day, month, short month. Day number, day, month, short month, calendar. I think I have the file. I actually have it. Then calendar, month, number. How many columns? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That was 14 rows, 14 column. How many column is there? 14 column. So that means I'm correct. So I've actually seen the correct column for that. I'll just go back to my transform tab, actually connect back to this dim invoice dates, which is a CSV file. Dim dates. Oh, I think it is a workbook file. Oh, dim date is a CSV file though. Oh, this is the dim dates. So this is the dim, it is called dim invoice dates. Okay, let's bring it in. Any step applied here. Promoted header, string data type, nothing much. I'll just delete this from here. It is called dim invoice dates. I'll just rename it as dim invoice dates. Interesting. So there's actually a solution to almost every challenge we have in with data sets. Close and apply. But I think DataCamp team need to do better. Wow. Come on, what is the challenge now? Uh, I think I need to get rid of this World Wide Web, whatever that is there. Since I've actually connected the data sets myself. So I have my actual data sets directly to my own data source. Let's give it another shot again. Ah, come on. Oh, come on. Oh, this is not fair. I did quite a lot of work trying to get this together. Can't I get rid of this actual table? Delete from model. So I can't actually delete it because it is being referenced, which is not supposed to be so. Because I didn't actually allow it to be referenced by other table. Ooh, that's quite interesting. But I'm going to do it again another time. So to just make a workaround around this, I'll make use of the part. Sorry about the time wasted there. I'm just going to make use of the this interface here, the DataCamp interface for this challenge, which is quite not fair enough. You can see the data sets here also. You can see, oh, this is not fair. This is not fair at all at all. What I could have just done is, let me look at what I could have just done for this challenge. Don't save, I won't save the file. I'm just going to open it one more time. Exercise file, calculated table. I was thinking if I didn't actually try to connect to the data source, since I'm not trying to perform any calculation, it should be able to work. Let's give it a shot for now, though. Okay. Because the instruction says navigate to the data view, create a new table called dim delivery date of the shipping date using a calendar. Dim delivery date function. Okay, so let's give it a shot first. If I try not to go to the Power Query editor view, I'll still have access to the data in the cache. So it says, okay, let me follow the instruction first. Create a new dates table called dim delivery dates. So new table, we're going to call it new table dim delivery date, which is going to be equals to using the calendar function. Take the minimum and the maximum from the delivery date key. Okay, calendar. So I'm going to take the start date. I think the start date will be the minimum dates. Min date from date key. Okay, let me look at the date key. So we should take the minimum from the delivery date key. Okay, delivery date key. Delivery date key, that is the minimum, comma. Then that should be the maximum delivery date key. That should give us our dim delivery date table. We have it there. So I can actually make use of the data set, even though I'm not connected to it from the data source from this table view. But that's just what's interesting to do. But let's continue like that. So next it says rename the column as dim delivery date table to match that of the fact sales table. Rename the column as dim delivery date key, dim delivery date. Okay. I'm to rename the column. Which column do you have here? Dim delivery date key. Is that what? Okay, dim delivery date. So I should name the column as dim delivery date. Interesting. We've done that. With delivery date key. So our dim delivery date, we've named it like that. So next one says establish a relationship between delivery date key, the dimensional table, and the fact table. You can use the manage relationship button to create it. Okay, if I go back here to the report, to the model view. So where is the these are our fact table here. So if I just drag this delivery date key, let me zoom in a little bit. This is better. The view is particularly relationship between this table here. You can see this whole file here is standing alone. This folder part is actually standing alone. I don't know why I can't change the data source from the end there, but that's by the way though. So establish a relationship between the delivery date key or the dimension table, this delivery date key, and you can use the money relationship to the delivery date key here. So the delivery date key is here. Let's look at it here. I just drag it here. So relationship should be, you can see, one to many. Relationship has been created. So we are on track there. So visualize the quantity of orders delivered over time by creating an area chart. Quantity of orders delivered over time. I go to the report view. But to bring in an area chart, this is an area chart. I want to visualize the quantity of orders, visualize the quantity of orders delivered over time. Order quantity. If I go to the fact table, I can look for the quantity, then over time. So over time should be so if I go to the team delivery date key, I can drop this here. Oh, you can see it is quite scattered. So drill down to quarterly. I want to drill down to quarterly. Click on drill down. I want to drill down by quarter. For this by year. This by quarter, you can see quarter one, quarter two, quarter three, and quarter four. Okay, interesting. So what was the quantity sold in quarter three of 2015? Quarter three of 2015. How do you know that in 2015? This is 2015. Okay. If I click on 2015, oh, no, I'm not formatting it. So since the data is up, if I click on 2015 here, it should deal in. So this is 2015. So I need to deal in. So this 2015. Oh, hold on a minute. July 2013, July 2013, July 2014, July 2014, July 2015, July 2016. Okay, let's see how you can go down to the quarter level. Hold up, hold up, hold up, hold up. Let me switch off the drill down button. But if I click on it, this by quarter, but it's not showing for which year. This for the whole year. But I need to do the quarter for the year 2015. Okay. Okay, so let's activate drill down. So I'm trying not to format it. But if I could click on this drill down, go to the next level in the hierarchy, it's going down by quarter. So if you are not sure which quarter is this, it says I want to filter to only 2015. Okay. So what I could do is you can see the dim delivery dates here. Hmm. Okay. So let's look at it one more time to figure it out. It says visualize the quantity of orders delivered over time by creating an area chart. Use the delivery date key from the new table and the quantity from the fact table. Drill down to quarterly level using expand all down one level in the hierarchy button. Okay, I think we're on track. Okay, we are using the quantity from the facts table. We have one quantity here, and we are using this dim table here. Okay, so this is 2015. So you can actually just drill down. If I click on, it says drill down to quarterly level using expand all down one level in the hierarchy button. Click on drill down. Okay, this is expand all down. It says what are the quantities sold in quarter three of 2015, July 2013, January 2013. Okay, there's no way you can actually see that from here. That's the challenge here. Because okay, let me add this to the legend then. Or let me just filter it based on this challenge here. Delivery date here, quarter. So I need to filter. If I filter bound by the year, filter on year is equal to 2015. Oh, I need to apply the filter. Year, I'll go to basic filtering. Is equal to 2015. Okay. And the quarter is going to be quarter 3 of 2015. So you see the quantity sold. If I look at the total quantity of orders sold in 2015, look at it here. So it will be quite, so it's giving us audio quarter of 2015. This is July, August, September 2015. If I drill up, where is 2015? If I drill down July, August, September of 2015, if I go back up a little bit, you can see it's actually the total for this. Now getting the total. If I click on show as a table, so what's the total here? You can see it's only the quantity of 2015, quarter 3, quarter 3, quarter 3. So the total should be this plus this plus this. Let me just get back to reports. The funny thing is I can't actually see the total, except I try to get it out myself. The total should be all of that added all together. So the total should be 4 over 49, 49, 5, 6, 6, 1. Oh, that's not correct. So even if I drill down one level and over it, I should be able to get the answer. Let me clear off filters there. If I go back to the report view, select all, then select all. So we are back to the normal filter view. So I say this is quarter 3, but we don't know which year it is. So that is the challenge there. 1953211. 1953211. 1953211. Sometimes I know that will be incorrect because we didn't do it down the correct way. And that's quite challenging right now. Maybe probably because I'm making use of. So I'm going to do this, give it a shot again. But that's one of the challenges you're probably going to face while trying to solve it. Sometimes it comes easy, sometimes it's just hard. You spend hours on it. If I read the instruction back, say establish a relationship, we've done that. Okay, now visualize the quantity of orders delivered over time by creating an area chart. Use the delivery date key from the new table and quantity of the fact table. So even though I want to use I may not decide to use an area chart. Let's use a normal table. Let's just use a normal table this time around. Let me use a normal table for this so that it will become easier. If I bring in the delivery date key, you can see it here. Delivery date key is going to show me year, quarter, month, day. Then I could just bring in the fact table, the quantity sold. Aha. So I could just see it from here like this. This is much more better and fair. So if I now filter it down now, then also if I go to 2015, this is 2015. This is 2015. This is quarter three, goal of quarter three. So rather than looking at it like that, I could just filter, apply filter, filter on the visual. So I want the year. The year should be basic filtering. The year should be 2015 because it's going to filter it to 2015, plus 2015. Then the quarter, I can come to the quarter part here. Then the quarter should be quarter three. That's it. So this is for the whole of quarter three of 2015. You can see it here. But that's correct. That is 699,626. Let's give it a shot one more time. 699, 699,626. Let's double check. 699,626. Wow, imagine. We finally got it. But after spending quite a lot of unnecessary hours there. That means using that drill down button, that bar chart, I haven't figured it out yet. That's quite interesting to see. So let's look at one more challenge to go. Calculated column for costs. So fact tables are typically only provided with the bare essential data needed. So sometimes you need to create extra calculated columns to find the answer to a business question. In this exercise, you create a cost column in your fact table. We want to create a cost column in our fact table. So navigate to the fact sales in the data view. So definitely, probably I don't need to just point to my data sets sources back, but I'll have loved to point to the data sources back. I'll just get rid of this. So we have a blank page back. So the good news is I can still work with the data table here without actually pointing to the data sets in the Power Query editor. That's quite interesting to note because all the data source will be giving me error. They are giving me error. So that's quite funny. I'll just cancel it and close. So I think we have the data. I think this is the cache part of the data source. You can see it is not even actually my own data set here. But it's quite interesting to see that it could work in Power BI, any file, but the transformation will be limited. Navigate to the fast sales in the data view and familiarize yourself with the content of the table. Change the currency of unit price, total excluding tax, tax amount, profit, and total including tax to dollar. Okay, let's take it one step at a time. Go to the fact table here, and fact sales. Want to change the currency of which columns? The unit price column. This is it here, unit price, total excluding tax, unit price. Okay, let's start one at a time. The currency abi, what are we changing? Change the data, the currency of unit price. Currency, what do we do that? Okay, it sends O number to dollar. We'll change it to dollar. Okay, the currency, let's change it to dollar yet. Okay, let's see. Okay, it's taking effect. Okay, interesting. Tax excluding also is there. We also have tax amounts. We also have the profits. Total including tax. To dollar. Okay. Okay, we've done that. So moving on to the next. Create a calculated column cost that subtract total profits from total excluding tax and convert it to dollar. Create a calculated column costs. Okay, we have to call the column a new column. We call it, what are we going to call this new column? Costs. Cost, which is going to be equals to um that subtract profit from total excluding tax from profits. So total excluding, is it excluding or including? Yeah, excluding tax minus profits. Profits. Okay, that should work. We could actually just use subtract function, but that should still give us the same thing. Interesting. I could just make use of the subtract function there. We are in 4.5. Let me see if that's not only what we have there. Okay, the values are quite different. But let me just make use of the subtract function this time around. Subtract. There's no function as subtract. That's interesting. See, I think that is the easiest way to subtract within the Power BI. I think we got that quite straightforward. Then create an area chart. Again, let's hope we won't have any challenge creating an area chart this time around. Go to the report view. Let's charts. So the area chart should show, create an area chart visualizing profit and cost over time using the date field from the delivery date table you created in the previous exercise. Same thing, profit and cost, delivery dates. Okay, let's look at the data we want to use. We want to use the profit and costs. Profits, with the profits column. Profit and costs. Okay, then the delivery dates. Oh, we're going to have the same. Is this an area chart? Let me look at the chart I selected though. Sure, an area chart. Now let's try to answer the question, because this chart just look uneven because of the date time period. Y-axis. Let me put the costs here. Even if the cost is on the secondary axis, we'll still be having almost the same view. Okay, so let's look at the question first. So the question says, in which quarter did worldwide importers make the most profits? Answer for maths. Y. Okay, year, quarter. In which quarter? Most profits. Okay, I need to in which quarter did worldwide importers make the most profits? Oh, drill down. In which quarter the most profits? Okay, you can see that the profit and cost here, they're almost the same thing. So when we drill down, we need to figure out which quarter. But it's only showing in quarters, the years are not showing. The most profits. Okay, let me put the profits. You can see the profits. So the axes are quite different. Maybe if I bring the profits together. Okay, let's see. Let's see the fact table. So we're having them in same axis now. Oh, interesting. Can see profit and cost, they're almost quite close. We could see by day here it's quite different. If you look at the year, the highest profits, look at the profits is quite high in 2015. You can see the year 2015, I think that's the highest profit. If you go a little bit down, so the quarter should be quarter two. quarter 2 of 2015. Let's see. Let's give it a shot because when I do back up, the year 2015 has the highest profit ever. Look at the profit and cost. The profit is quite high than the cost in that year. If we come down a little bit to the next hierarchy, which is quarter, that should be quarter 2, quarter 1 year profit 24,011, 24. So let's say 2015 quarter 2. Let's say 2015 Q2. Oh, we nailed it. So I actually got the area chart drill, but I didn't just pay attention to it. So when you drill down a little bit, okay, let me go back up a little bit. I think this is the first step in the hierarchy. According to this, you can see the hierarchy, which is year, quarter, month, day. So if you look at the year, the highest year should always have the next level, highest level. So if I go back down a little bit, the quarter, so 2015 quarters are the one showing here as the highest. If I go down, the 2015 quarter 2 or whatever quarter you're looking at is the highest here. Oh, okay. Maybe that's one way to read it. But it's quite interesting to know that we know it there. So let's do date cleaning with, okay, we have one challenge to do. Date cleaning and connecting data from different tables. The next challenge is the date cleaning challenge. Sometimes you have to clean up existing columns before you can create new calculated columns. We want to add the retail price to our fact table for an item, but the retail price in the dimension table is not formatted correctly. You will be cleaning up this column so we can add it afterwards. Let's investigate the recommended retail price column from the dim stock item. Recommended retail price. Let's look at that. Look at the dim stock item. Recommended retail price. This is the unit price. Unit price is 32. Okay, let's see. Oh, the unit price is quite, it varies. Okay, look at it here. It's recommended retail price column. Look at it here. You can see recommended retail price is 47. It is not well cleaned. Can that it is not well cleaned. We're having a question mark before each record there. Okay. Create a new column and name it retail price clean. Replace the question mark with a blank by using the substitute function. Okay. Want to create a new column. Want to call it recommended retail price clean. Create a new column and say retail price clean, which is equal to substitute. The text I want to clean is this recommended. What I want to clean is the question mark there. And then I need to put the question mark in double quotes. I want to clean it with a blank. Let's see. Aha, so we've done that quite easily. That's interesting. Okay. Sort the retail price clean column in ascending order, which non-numeric character is present in the first row. Okay, we should sort it in ascending number. Sort ascending order. Okay, non-numeric character will be present in the first row. You can see that's correct. Okay, which non-numeric character is present in it? That is a dash. So we nailed it there. That's pretty straightforward, though. Very straightforward. I think the last challenge here is connecting data from different tables. So you are asked to add the suggested retail price, the one you cleaned up in the previous exercise, to the main fact table. That's where you can perform additional analysis in the future. So to the fact table, okay, we need to create a new column, retail price, in the fact table, in the fact sales table, to pull the retail price clean using the related function. The Power BI, we know what to do because the relationship between the fact table, both tables already established. If you look at the table here, this is our, if I go to the model view, this is our stock item table, and it is actually connected to the fact table in the stock item key. So from that, we can pull, based on the key column that we have here, you can pull any column from any of the tables, vice versa to each other. We want to pull this retail price clean here, retail price clean, this column here. I want to pull it inside this fact table. I'll just go to this fact table here and create a new column called retail price. Create a new column called retail price in the fact sales table. You call it retail price, new column rather. We call it retail price equals to related function. I'll just look for the clean retail price clean from that column, from the dim stock item, and lock it in. We're just going to drop it here based on the what? The stock item key here. Where is that stock item key? This stock item key. So that's what it's used to bring forth this new column from this stock item table here. So that's quite interesting to see there. So definitely have to answer a question. So to log that in. So the retail price in ascending order. You notice that, okay, let's start it in ascending order also. Oh, we didn't have any dash there. You will notice the dash value disappear. This is happened because the dash value was related to an empty row. So that's interesting. We don't have to clean this column anymore. So let's reformat it in the next step. So change the data type of retail price to decimal number or format as currency. We change the data type instead of text, change it to decimal number. Decimal number. Okay, and let's change it to currency. You can just click on format as currency. Let's format instead of general, let's format as currency. We should add a dollar sign to it. Interesting. So what is the highest retail price in the fat sales table? Highest retail price. You have to sort it descending this time around. So the highest retail price is $2,893, $839.00, 0.1 cents. $2,835, $839 rather, 0.01. Ooh, what is the highest retail price in the fat sales table? How am I missing this? Oh, I wrote 838, no, 839. Correct. Good job. Having the recommended retail price in our fat sales table will be very useful for future analysis. That's quite interesting to see. Sorry, we have to spend over an hour on this because we're trying to make sure we connect to the data set, which can sometimes be unnecessary because it's only when you're working within Power Query that you actually need to connect back to the data source to work. That's quite interesting to see. So we finished this setting up data model with DAX. DAX and just is the next challenge. So I'll just save this file. Let me look at what we're doing next. Method creation, advantage of explicit DAX measure using variables based statistical class, quick measures. That's quite interesting to see. Alright, so thanks for staying to the end of the live stream. So if you found value in this live stream journey with me and learning Power BI with me, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and do well to put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. As usual, I'll see you on day 41. And sorry about this live stream. We're trying to troubleshoot the data connection, data source challenge in the Power Query editor. I've done it quite a lot of time, but this time around it was quite different from what I'm used to doing, or changing data source to a new data source within my own Power BI local machine here. All right, all the well. I'll see you on day 41. Bye as we continue.